Hello and welcome to C++ Weekly. I am your host Jason Turner, and I am still available for code reviews and on-site training. I would like to call your attention to the fact that I am doing a workshop at NDC Tech Town in Kongsberg, Norway in September, and a workshop at C++ Under the Sea in Breda, Netherlands in October of 2024. Okay, this episode is one that was submitted by one of you on the episode tracker list for C++ Weekly. And I thought it was a good idea for an episode, and I thought I would go ahead and record it now. And the basic idea is, how do I get the pointer to an overloaded function? Now, the original question was specifically around functions that are part of the standard library, but really it's a generic question about overloaded functions. So I'm going to write some sort of a function, and I'm just going to give this thing no definition at all. I just declared a template function, Ford declared it. We're not going to be able to execute this thing, so we're going to turn that off in our compiler explorer. And we are going to have some sort of function. Let's call it a callable. And this one is going to take an integer. And it's also going to be intentionally Ford declared. Now, if I say use callable, and I pass it a pointer to this callable function, then this code is going to compile and the assembly is going to be very straightforward. It loads a pointer to the callable and it calls the thing called useCallable, and we can see that it deduced here that it's a function pointer that takes a single integer. Now, as soon as I add a single overload to this, I now get a compile error. No matching function for call to useCallable. Candidate template ignored. Couldn't infer template argument. Okay, so now if this actually requires a function pointer that takes an integer, is this going to compile? This does compile because there's only one possibility here. And if I declare a callable template function, then this also compiles, and this is because it has been able to coerce this, it's a template function, into a function expecting a single integer parameter. Now let's go back to this generic version, and we will get to the crux of this problem. I can static cast this to a function pointer that takes an integer with this rather ugly syntax, and I can make that first line compile because I know that there is a version of this function that takes an integer, or I can take a double. But if I were to try to cast this to a function that takes a float, then this function can't compile again because it can't find an address in this function overload set for something that matches a function that takes a float. Let's get this compiling again, and now we're going to do the same thing with the static cast of this template function. And in this case, it's a template function. So as far as the compiler is concerned, this thing can take literally anything. It just has to be a single parameter. So I can make this a float, or I can make it a double, or I can make it a car, and it's able to do that cast and stamp out a version of the template that takes a single character pointer. So you have to do this if you've got template functions, or if you have functions with an overload set. The alternative is to do something like this. And what I've done here is I've wrapped this around a lambda. Now this is still a generic lambda in this case, and you can actually pass generic lambdas. Now, I'm not entirely sure why the compiler is requiring that a definition of useCallable be available here, but let's just go ahead and give it a fake definition, which is unfortunate because it makes the whole rest of this thing go away. Let's see if GCC is slightly more lenient just so that we can keep playing with this without having to have an implementation available. It is not. All right, fine. So a lambda is another option. But the question is, why is the lambda allowed in the case when the other things weren't allowed, even though it's a template function. And the key comes down to the fact that lambdas aren't actually functions, they are structs. That kind of look like this. They have their own call operator overload. So the lambda itself is not a template. The closure object type is not a template type, but it has a member function that is itself a template type, which is why I'm allowed to pass a generic lambda to this thing. Now, this is ugly and hides some inefficiencies. If we really truly wanted to do this as efficiently as possible, we end up writing just nonsense like this, where I have to end up taking a set of parameters as forwarding references, properly forward them decal type auto to maintain the return type from the thing so that I avoid doing copies, extra copies that are unnecessary in and out of this function. So you can wrap it in a lambda, but you really just have to generally play some games for how you want to do this. Now, there have been some people, and I'm not going to say that I would necessarily recommend this, that have done things like this. So what I've done is declare a macro for myself that does this forwarding thing with a decal type auto return value, and then basically this overload just wraps this callable thing by name into a lambda as a macro. And again, I don't recommend this, but really the point is there's no way, unless the type system forces it, to disambiguate between overloads and an overload set in C++, and there's no way to pass an overload set in C++. So we have to do something. We have to static cast it or wrap it in some other type of callable thing so that this all does what we want it to do. Well, so thanks for watching this relatively disappointing episode of C++ Weekly. I hope you enjoyed it. Be sure to subscribe, leave a thumbs up, all the things.